Hello everyone and welcome to our video in which we are going to look at how we can read analog input values using Arduino Uno microcontroller. In this case, we're going to practice on how we can perform analog signal read and write functions. So in this example, we're going to read an analog value from an analog input pin. Then we convert that value to a PWM signal by dividing by 4 and then outputting the PWM signal on a PWM pin. In this case, we're going to use pin number 11. So this is the circuit layout. We want to draw the circuit in Tinkercad. Basically, we have the Arduino Uno microcontroller. We have LED, which is the indicator device, a resistor to protect the LED from excessive current. A 1 kilo ohm resistor can do the job. And then we have a 3-pin potentiometer, which is basically a variable resistance input device. The potentiometer here outputs an analog signal. It has got 3 pins. We can see that there are 2 power pins, the VCC and the ground, and then the central leg, or the central pin is the signal pin. But before we draw the circuit diagram, we can quickly run through the code. And then after the code, then we can, after testing our code, then we can do the circuit and then test its functionality. So in terms of our circuit layout, let's take note of our circuit design. So what I want us to have in the case of our circuit layout, components are not many here. Let's have our LED, the indicator device, connected to pin number 11, which supports PWM. Then let's have a potentiometer connected to the analog pin number 0. So this one, let it be connected to analog pin number 0. And then let's declare a variable by the name value and then use it to store the read value. So this one is a variable to help us store the read value. Help us store the read value. So I'm going to do the code here within the Arduino IDE environment. I'm going to do the code within the Arduino IDE environment. So let me start the Arduino IDE application. So let me start the Arduino IDE application. So here we go. So in this case, let's begin by declaring an integer variable for the LED. Let's call it LED, then we assign it to digital pin number 11. So this one, we want to connect our LED to pin 11. Then another integer variable, we can call it port, that's for potentiometer. Then we can let this one to be analog pin number 0. So basically here we are connecting potentiometer, connecting the potentiometer. We are connecting the potentiometer to analog pin number 0. Then let's declare a variable. Let's call it value. And then we initialize it to 0. So we want to use this one as a variable to store. It's a variable to store the read value. Then under void setup, we can now, the value here should still be integer variable. Then under void setup, you can put the analog reference function, or you can leave it blank. If you want to put analog reference function, and of course, you can put which one you want to use here. For example, you can come here and put, say, analog. Then you put reference here. Then you specify the function, the value of analog reference you want to use. For example, you can put default there. But in our case here, it is not that necessary because the Arduino Uno microcontroller I'm using, we are going to power it at 5 volts, but it can also be powered at 3.3 volts. So this one is basically optional. Then I have under the void setup. So I think that is what we can have under the void setup. Then now for the void loop part. For the void loop part, we can now have that value we've declared up there. Let's use analog read function. So I can put analog read, the value we read from the potentiometer up there. So basically, in this case, we are going to set a value equal to the pin 0. The pin 0's equal to the pin 0's input. And then we convert it to PWM by dividing by 4. So to PWM, we can divide it by 4. So we will say value. Then we divide by 4. So the new value will be the original value divided by 4. And this way now, we will be converting. So this way now, it converts for us. The original value within the range 0 to 10, 23 to 0 to 255. So that is a PWM signal, which we can now write to a PWM pin using analog write function. So analog write to LED here. So we use it the same way we had declared it up there, LED, comma, then this value, a new value here, which has been divided by 4. So in this case now, we output PWM signal to LED. Output PWM signal to LED. So basically, this is now our code. We can test it. So we are compiling the code. So it is free from errors. Now we can switch over to Tinkercad and set up the circuit. So in Tinkercad here, I can bring the Arduino Uno microcontroller. Then we can bring a small breadboard. A small breadboard. Can put it there. Then we can search for potentiometer. So we can search for a potentiometer. Click on that, pick the potentiometer, put it there. Then we can search a resistor, pick a resistor. Put it there. Then we can search LED. Pick LED. Come put it there. So this is the cathode. So let me connect it that way. This is the anode. Then we can come tap VCC 5 volts. Bring it here. Give it a red color. Come tap ground. Bring it here. Give it a black color. Then connect that to VCC. Give it a red color. Then connect this one to ground. Give it a black color. For the potentiometer, this terminal 1 is ground, and this terminal 2 is can be VCC, so we connect it there. Then we can connect terminal 1 to ground. It's black. Then the wiper is the signal, so we can tap it. This one we are taking to analog input pin number 0. We connect it to analog pin number 0. Let me give it a green color. Then the LED is connected to PWM digital pin number 11. Let me give it a purple color. In the Arduino Uno microcontroller, you can see these pins with the tide, they are the ones which support PWM. So like a pin 11, pin 10, pin 9, pin 6, pin 5, and pin 3. Those 6 pins support pulse width modulation functionality. So we've properly wired the LED to the Arduino microcontroller. It is powered up. The potentiometer is powered up and also properly wired to the Arduino microcontroller. So we can bring our code, the code we had written and debugged on the Arduino IDE environment here. So we can import our code, go with it to Tinkercad. Then put our code here. So I said that the analog reference here, the specification of analog reference here is optional. We can still do away with it because the default analog reference is already captured here. This one here is the analog reference pin, which is usually used when you want to specify this. So when you want to specify that, then now you'll have the signal fed there. And that is the reason as to why now in this case, that function may not serve any purpose, although even its presence there causes no harm. So that is the code. Then now we can now label the circuit. So this one here is the potentiometer. This one is the potentiometer. Then this one is the Arduino microcontroller. Is the Arduino microcontroller. Then we have this one here being the resistor. Then we have, so that is the resistor. Then we have the LED here. This is the LED. And then we have the breadboard here. That is the breadboard. So that is our circuit. And the code is here. This is the code we had written. So we can basically now start the simulation. We can start the simulation. So our simulation is running. Now we come to operating the potentiometer. It has got a slider, which you just click on the mouse and then you operate. As you can see now, at some point the LED comes on. When we put it minimum, the LED is off. In this case, I've set the value of this potentiometer to be 250 kilo ohms, but you can always make adjustments here. You can change the units there, and you can also change the values here. Like if I'd put maybe this value as, if I'd put this value as, say 10 kilo ohm for the potentiometer, then now you see now when it comes there, now it is on, it stays on. And then when it is down here, it goes off. So if I put maybe the value of this potentiometer to be, let's say maybe 1,000 kilo ohms, then expect it to stay. If now we change it now, you see, it is coming on early. It is coming on quite early because we are using a PWM signal. Otherwise, if we are not using a PWM signal, then we will have to go beyond the midway point for the LED to come on. But now this one, because we are using a PWM signal, as you can see now, the strength is varying, whereby the LED is changing from a dim color, like there it is totally off, completely off. Then now it will light dim. The brightness increases. As we increase the power to the LED until we get the brightest possible color. So maybe assuming that we wanted to operate more than one LED, then I can now come and, for example, maybe add another LED here. Then I can come add another LED here. Let me give this one a different color. Let me give it green color. This one here, let me give it a yellow color. Then I can wire this cathode here to ground. Then come also wire this other cathode here to ground. Then I can put a resistor here. And then I can put another resistor here. Maybe let me take it this side. Then I can now connect this side to VCC. Then I can pick this one, connect here, then pick that one, connect to VCC. Then I come and connect the signal wires again. And connect the signal wires. So that way now we'll be able to operate the 3 LEDs using a single input device or potentiometer with the same code. So if I start the simulation now here, all the 3 LEDs are lighting. Then of course now we can turn all of them off, okay? So here now they are operated together, okay? And now maybe if you have multiple input devices, or maybe if you have 3 potentiometers, then you can connect to each of the LEDs. So thank you very much for listening to me. In this example, we've looked at how we can use Arduino microcontroller to read analog input signal, convert that value to PWM form, and then use analog write function to send out the PWM value. This kind of problems or scenarios are common in the industry, especially in scenarios where we want to run motors using digital control means. In case you're watching this channel for the first time, kindly take a moment, hit the subscribe button. You can also like the video. Kindly also share with your friends or colleagues who may be interested in the content covered here. Thank you. Bye-bye. In our next video, we will look at the delay functions as it pertains to Arduino microcontroller programming. So watch out for that. Thank you. Bye-bye.